Okay, so on Friday, your curve that we looked at, or on Thursday, whatever, the curve you looked at, we looked only at the percentages given when you're +1, +2, +3 standard deviations away, or -1, -2, or -3 standard deviations away. So all we looked at was the exact percentages of those. So we know that this is 34% here. This is 34% of your data right there, right? This was what, 14 and a half? 13 and a half, thanks. 13 and a half, and then 2.35, and then 0.15, and then the same thing over here. 13.5%, 2.35, and 0.15, right? So 50% of your scores, so if you took 100 test scores, 50% of them would be on that side of the average, and 50% would be on this side of the average. And then we said, okay, well, what if your score was 1 standard deviation below? How many scored less than that? How many scored greater than that? Well, 84 scored greater, 16 scored less, right? Okay, so that's all it was. But we focused only on the actual standard deviation intervals. But that's not how this all only just works, okay? So for example, let's say, well, let's use this. Let's say I have 80 here, and my standard deviation is 5, so that makes this 85, this 90, and this 95, and then 75, 70, and 65. Okay, so what percentage of the scores were greater than 70%? What percentage of the scores were greater than 70%?
97.5.
97.5, right? You add up all of those percent values, and we know that greater than that value was all of these percents. So that means then that over 97% of the scores would have been larger than 70%. Okay? But what happens if a student scored about a score on the test of 82%? And I said to you, I want to find out how many scores were better than that, and how many scores, or how many people got better than that, and how many people got less than that.
Mr. Wilson, to the office, please.
So that's what we're going to do today. This is called what we call Z-scores. So we take an actual average, which is from this scale down here, and we find out what percentage scored greater and what percentage scored less. So how this works is this. We have an equation, a simple equation. It's called the Z equation, the Z-score equation. All right? And you take your actual score minus your average. Now notice they have a different symbol than that symbol for average. They use a little micro symbol for it. Okay? And then you've got your standard deviation on the bottom. All right? So what I can do then is I do this. I take my 82, I subtract my average score, which is 80, and I divide it by the standard deviation, which in this case is 5. Okay? Average 80, standard deviation, each interval is 5, and I find out what this is. So I subtract it, I get 2 over 5, which is 0.400, right? 2 divided by 5?
Oh, sorry.
Right? Now, how do I find out how many people scored greater or less than that? How do I find that out? I use that decimal value, and I go to the back of my book. And at the very back of the book, on page 294, 295, is a chart. So you want to open to this chart. Everybody wants to open to this chart, Justice. What page? 294. 294, 295. All right. So looking at this chart now, it will give this to you in 2 decimal places. Two decimal places. All right? So you notice down the left-hand margin is the tenths and the ones. So for example, the very first score is minus 2.9. Now to get it in the hundredths, we go across the top. So in this case, my value is 0.400. So I'm looking on page 95, and I go to 0.4, and then I go across to 00, Lachlan. So what's that decimal that I get? That's because you're not paying attention. Go down the margin on the left to 0.4, the other page, the positive one. And now go across the top to 00, right? And what's the value? 0.6554. So what is that? That means that that score of 82 scored higher than 65.54% of the people that wrote the test. Okay? Now I want you to make sense of that. Where does, on this chart right here, on this bell curve, where does 82 occur? Somewhere in here, right? So we know it's greater than 50%, right? And less than 84%. So it's somewhere between 50 and 84. Well, does this fall between 50 and 84? Yeah, and it's a large range, right? So how does that range shrink? Well, your standard deviation would have to be smaller for that to work. So all I do is I use the chart and find out what percent scored less than that. So in this case, it's 65.54. All right, so let me test your ability to do what we just did. I want to find out the percent that scored less than somebody who got 77% on that test. So you have to start by using your z-score up here to find out what the z-score is. So 77 minus 80 over 5. What do we get?
Negative
0.600, right? So we actually only want to go to 2 decimal places for this chart. So looking in your book, go down to minus 0.6, go across to 00, and what do you get?
0.2743.
0.2743. So that means that score of 77 was higher than 27% of the people on that. Does that make sense? Well, where does that one fall? It falls right here, right? Okay, so how much is this percentage right here? Well, that's 16%, right? From here to here is 16%. So then add a little bit more, takes us up to 27%. So the difference between what we did on Friday, or what we are doing Thursday and Friday, is we were using the exact values of the standard deviations. And now we're going to use parts, or the values that are in between these values. And all we have to do is just use this equation right here. So the first thing you'll do today is put that onto your cheat sheet. All right. Let's look at the example that they use in the book. The mathematics score. Test scores in Ramon's class are normally distributed. The mean is 80 with a standard deviation of 5. Callie is in Ramon's class. She scored 83 on the test. Compare her score with the rest of the class. So I used 82 up here. She used 83. So if I used 83, it would be 0.6. And then you would find out that it would be on the chart. She would see that it's greater than 72.57%. Okay? Now, let's take a look at example 2. This one's completely different than the one we just did. The mean lifespan of a non-sticking frying pan is 2 years with a standard deviation of 0.5 years. Carney is an avid cook and wants to replace her frying pan after 65% of its natural life. When should she replace the frying pan? Assume that the lifespans of this type of frying pan are normally distributed. Okay, so now, what's the average life of the frying pan?
2 years.
2 years? Okay, and the standard deviation is
0.5.
0.5, so that takes that to 2.5, 3.0, okay? And this will be 1.5, 1.0, and 0.5. And it's the 3.5 right here. Okay. Now, she wants to know when she's going to replace it in order to her frying pan after 65% of the normal life. So, this guy, what we did to get the solution for it, right, was we needed to find out the score minus the average divided by the standard deviation, right? So that's what these symbols are. That's your score, or how much. That's your average, that's your standard deviation. That gave us the z-score on the chart. And then we used the z-score on the chart to find out what percent it was. Well, now I know the percent. So I need to find the z-score from the chart now in order to find out what that value is right there. So the first thing I want to do, I'm going to use this equation. What do I know? I don't know x. I know my average is 2. I know this is 0.5, so what do I need? I need to get my z-score. So now you go to your chart. So everybody flip back to that chart again. And this is the part that usually confuses people. Now I'm looking for 65% on the chart. I want to know what the z-score is. So looking at the chart now, find out where on the chart you're going to get as close to 0.6500 as you can. Where does 0.6500 fall?
Somewhere between 0.408 and 0.409.
You're a little high. Yes, Bree. What is it?
0.3 and 0.0.
Yeah.
Yeah, so between 0.38 and 0.39, right, would give me a z-score. So how about we break it down in the middle? So 0.385, because it's somewhere in between 0.38 and 0.39. Does anybody not know where that value comes from? Okay, I'm looking for 0.65, right? So there's close to 0.65, there's just above 0.65, right?
Okay.
So now I go across, that's 0.38
Okay.
and 0.39, so I'm gonna go halfway in between. Anybody else need me to show them that? Okay. So there's 0.65, close to it, there's just above it, right? So now I go back to here, that's 0.3, and I come across and look up, 0.38 or 0.39.
Okay,
So I'm going just in between.
use that.
So that's my z-score. So now that I have my z-score, look what happens next. Okay, I have my z-score. So now I'm going to times that z-score by 0.5. So 0.385 times 0.5.
0.1925.
0.1925 is equal to x minus 2. So how do I get x? Add 2. So what does that tell us? That if she wants to replace it after 65% of the lifespan of its natural life, she'd have to replace it after 2.1925 years. Okay? So this question here, I had my x, I needed to get to z in order to get to here. In this question, I had the percent to get to z to get to this. So you see how that works? So they're the same style of question. I'm still using the same stuff, except this goes from here to z to percent. This one goes percent Z to the X. And that's all there is to it. All right, any questions? And again, it's just using that chart. You'll get the chart for the test. Okay? All right, that's all I have for that.